Let's take a look at how this Rishon-like model can articulate the quark masses in a manner that is proportionate to the articulation of the masses in the standard model. So first we're going to take a look at the T-quark, which is the top quark, or the most massive of all the quarks in the highest generation. And first we'll look at a mass which we have assigned to what we may call the generic D quark. And we have assigned a mass approximate to the S quark of about 500 electron units. Now, the T quark then is composed of a generic D quark and then a flavored boson plus. And so masses are given to the higher generation particles by multiplying the masses on the generic, or the intrinsic masses on the generic quarks. And it's done by assigning a factor to the flavored, the prime, and the generic Rishons when they're in this configuration of a boson plus or minus, or any boson, a scalar boson. And so here we have 100 factor assigned to this flavored V Rishon. And here we have a T Rishon which has a factor of 2. So together this will be a factor of 200. But this is a boson plus, so it's going to have an electromagnetic interaction with this generic D, changing it to a generic quark of 2/3. And the mass units on a generic quark of 2/3, what we call a generic Q, will be 5 times that of the generic D, which would be 2,500. So we should have 2,500 times 200, and that will give us 500,000 electron units on the T or top quark. Now let's look at the composition of B quark according to this Rishon-like model. We have a generic D and we have 2 boson zeros. This boson zero being composed of a flavored and prime, and this one being composed of a prime and a generic. Now, in this approach, when a flavored Rishon and a prime Rishon are composed together, they cancel their mass factor, which means they will not couple the generic D quark to the Higgs field. So this scalar boson plus will not increase the mass on this generic D quark. But here we have a prime and a generic. And in this case, we will have a coupling and a factoring of the mass on generic. Unlike the flavored, which is a factor of 100, the prime is just a factor of 10. And of course, as before, the generic Rishon will be 2. So we have 10 times 2, which will be 20 times the 500 that will be on the generic D. And we'll see that that will give us 10,000 electron units, which is proportionate to the T-quark as predicted by the Standard Model. And so let's continue now looking at the C-quark and the S-quark. Now, if we look at the C-quark, we'll see again we have generic D, which gives us an intrinsic mass of 500 electron units. But we have a boson plus. Now this boson plus will not provide us a factor in its coupling with the Higgs field, but will provide an electromagnetic factor. The electromagnetic factor will be 5 times the units given by the D quark. So when we click here, we'll see the mass on the C quark will be 2,500 electron units. And if we now look at the S quark, again we have the generic D giving us 500 electron units, but in this case we have a neutral boson, so it will not have an electromagnetic impact or factor on the D quark. And so therefore, though it will carry the appropriate flavor, weak isospin, and other quanta that's necessary for it to be defined as the S quark, it will not increase the mass on the generic D. So for the S quark, the mass on the generic D will be 500, approximately 1/5 of the C, which is an approximation consistent with the Standard Model. And so there we have, for the highest generation and the middle generation, we see that by assigning factors to the flavored, generic, and prime Rishon, that the compositions which are necessary to give us the appropriate quanta also will give us proportionate masses consistent with the proportions in the Standard Model.